আজকে আমরা করব ওয়ার্ক এন্ড পাওয়ার, ওয়ার্ক ইন ফিজিক্স, ফোর্স মাল্টিপ্লাই ডিস্টেন্স মুভ। যখন একটি অবজেক্টকে মুভ করানো হয় ফোর্স দিয়ে and it moves a distance, then that is particularly work has been done. When force given to an object and it moves a distance, then we can say that work has been done. And work done equals to, that's why force multiplied distance. So we can underline this. Work done equals to force multiplied distance, and work done, it is expressed W in joules, force in newtons, and distance moved in meters. So W equals to F multiplied D. And work done is equal to amount of energy transfers. Remember, work done is also equal to amount of energy transfer. কতটুকু এনার্জি ট্রান্সফার করা হচ্ছে তার উপর সেটা, এবং ওয়ার্ক ডান হচ্ছে ইকুয়াল। Look at this, there is a math problem here. This person, he is lifting 500 newton of weight in 2 meter. So he has lifted 500 newton of weight, and the distance moved is 2 meter. So what is the work done? Force multiply distance, 500 multiplied to 1000 joules. This is the work done. And what amount of energy he transferred? Similarly, 1000 joules of energy he transferred while lifting this object to a height of 2 meter. Another example here, you can see a car is moving right side in right direction at 30 meter per second. So 400 newton of force on car driving it forward, and 400 newton force opposing due to the air resistance and friction. So what would be the work done? Now it is moving a distance in right side, is moving a distance towards right side. In every 1 second it crosses 30 meter of distance. It is written here. In 30 meter distance it crosses in every 1 second, and it gives 400 newton of force. The car gives 400 newton of force. So work done equals to 400 newton multiply 30, 12,000 joules or 12 kilojoules. Both forces are equal and opposite, means the car is moving at constant velocity. It is written here, the car is moving at constant velocity, constant speed, because the resultant force is 0. Now come to the point, gravitational potential energy. Gravitational potential energy is defined as mass multiply height multiply gravitational field strength. And underline this way. Mass in kilogram, G is the gravitational field strength in newton per kg, and H is the height in meter. So when you lift an object, when you raise an object to a height, it gains an energy that is called gravitational potential energy. I repeat, when you lift any object to a particular height, it gains an energy which is called gravitational potential energy, and GPE, it is equals to M multiply G multiply height. Look at this. Look at this. This is the object. This is the object, and it has mass of m kg. So its weight is mg Newton. you know, weight equals to mass multiply G. So M multiply G, mg Newton. Newton is the unit of weight. Now with the force of F, it has crossed the distance of h meter. H meter. H is the distance and meter is the unit of distance. So with the force of F Newton, it has moved, raised up a distance of h meter. So work done equals to mgh. This is the work done. Work done is mgh. Now, similarly, when this object now is in a higher position, it has GPE maximum. For example, the ball is here and you are going to release the ball from a particular height. The ball is here in a top position in your hand. So the ball has GPE and the GPE is maximum for this height. For this height, GPE is maximum and kinetic energy is 0 because it is not moving at all. Kinetic energy is the energy an object has when it is moving. So this object is not moving, so kinetic energy is 0. Now the object is released from this place. So as it released, the height is decreasing from the ground, and you know GPE equals to mgh, mass multiply gravity multiply height. As you released, height is decreasing, so GPE is decreasing. Now it is moving, so KE is increasing. And interestingly, the GPE is losing that much energy. It is converted into KE. That much energy is converted into KE. It is losing GPE and it is gaining KE. And just before hitting the ground, look at this. Just before hitting the ground, GPE becomes 0 because height is 0 now, and KE is maximum. That GPE is converted into KE. That whole GPE is converted into KE. KE is maximum. And after hitting the ground, the energy transferred as heat and sound energy, and object sometimes it deforms. Not all object deforms. Object deforms. Sometimes it deforms and we cannot trace it. So this is a very important diagram. And look at this KE. What is KE? We can find out KE by using this equation. KE equals to half mv square. M is the mass of the object and v is the velocity of the object in meter per second. M is the mass of the object in kilograms always. If it is given in grams, you have to find out in kilograms. Kinetic energy KE in joules, it is equals to mass M in kilograms multiply velocity squared or speed squared in meter per second. So KE equals to half of mv square. Now there is a math given here with KE. A meteorite of mass 500 kg hitting the earth at the speed of 1000 meter per second. What would be the KE? So KE equals to half of mv square, half multiply 500 multiply 1000 equals to this much joules or megajoules. Look at this. There is all GPE and no KE. An object is in a top place, is a particular height. So everything is GPE. There is no KE. So when the object it released from the particular height, is gravitational potential energy gradually decreasing and Ke increasing. Ke is increasing and gravitational potential energy is decreasing. Just before hitting the ground, all the Gp is transferred to Ke. Just before hitting the ground, all Gp is transferred to Ke. Just look at this diagram. So Gp is decreasing gradually and Ke is increasing gradually when it is falling. For a falling object, the graph of Gp and Ke, energy time graph, Gpe decreasing, Ke increasing. So Gpe is converted into Ke. And this is actually the work done. The GPE, when it was maximum, the work done was like that, GPE, and when it is converted into KE, that is also work done. So what we can say, the work done for lifting the object is gain in GPE is equals to gain in KE of the object just before hitting the ground. The work done equals to GPE equals to KE, or you can say work done equals to gain in GPE equals to gain in KE. And it means energy is conserved. Look at this, because when you lifted the object, work has been done. Now this work has been done is converted into GPE. It is not lost. Now it is into GPE. And when you release the object, the GPE is converted into KE, energy is still not lost. In this concept, we can say that energy is conserved. So the loss of GPE is equal to the gain in KE. Energy is conserved means energy cannot be created or energy cannot be destroyed. Energy just transfers from one form to another form. And there is a math given. Try it here yourself. It's a very simple math of a roller coaster. GPE and KE relates. mgh is GPE, K equals to half of mv square. In both sides, m cancelled out. gh equals to half v square. And put the values given here. H equals to 17 meter. Put the values here. And you know G equals to 10 Newton per kg by default. It is always 10 Newton per kg on Earth. And you put the values, you get the final velocity V 18.44 meter per second for this roller coaster. For this roller coaster, what is given? That it is falling through a height of 17 meter. Calculate the track speed at the bottom of this fall. That's the speed that we got here. Now is the equation of power. Then how can we deduce power? By using work done and time. So this is the equation of power. Power equals to work done divided by time taken. And its unit is watt, according to the name of famous scientist, James Watt. And 1 watt of power means 1 joules of energy transferred in 1 second. I write it here. 1 watt of power means 1 joule of energy transferred in 1 second. So if it is 10 watt of power, it would mean 10 joules of energy would be transferred in 1 second. So 10 watt of power means 10 joules of energy transferred in 1 second. So here there is a simple example given, that a motor and a lift with passengers, it has weight of 4,000 Newton and it is lifted up every second. 1 second it lifts 3 meter. So what is the work done per second? So 4,000 multiplied 3 meter per second, 12,000 joule per second, or 12,000 watt. Is the work done per second, and work done per second means power. So it is power. You can say that this is power equals to 12,000 watt. So yeah, there are some simple examples given. I hope that you solve these examples and try. If there is any problem, we will solve these answers for. That's all about this chapter. We finish here, and next class we will be reading chapter 17. Thank you.